To represent the quantum mechanical model of the atom, Austin and I chose to use a football field. The field is the nucleus, and then the quantum numbers 1, 2, 3, and 4. The first quantum number would be the first section around the field, the closest on the field. And then it goes up, and you can go out here, so then it separates the first and second levels. Second quantum number is second level. It's still closer to the nucleus, but um, in the field we're looking for a hot dog vendor, and we're trying to figure out what section he's in and where he is, and where he is compared to the nucleus, which is the field. So then the quantum number 3 would be this area, which is the food area, the bathrooms. It's where all the press boxes are, and that has a different shape because it goes outside more. And then if we're moving up to the fourth quantum number, that's the upper deck. The upper deck has more of a trapezoid shape right here, and then it fans out. And that's the widest one. That's why it's the quantum number 4. It's the fourth level. And if we knew if he was in 1, 2, 3, or 4, we would know which orbit he's in, because the orbit is just the perimeter. And then if we knew which orbit he was in, we could find the orbital, which is the specific area inside. More specifically, the rows, because normally benders go in rows. So if we could find out which section he is in the orbit, we could find out which orbital or where he is in the orbital. Awesome.
The difference between the Bohr's model and the quantum entanglement one is that the Bohr's model, it's 2D, it's flat. Can you see this? It's like flat, and there's just little like lines that like show like how like flat it is and like how it's like not three-dimensional, and how like they think it's just like a flat like circle almost. And then how our football field represents a 3D because it's more like 3D, like the stands is like up more, and there's like stages and that like stages that it goes up, and it's almost kind of like a dome, I guess. And then our example of the quantum entanglement device is this basketball, because unlike the Bohr's model, this quantum mechanical, it's 3D, and it's like there's like air in it that it could be like it's just floating around there instead of just like being in like a paper, just a flat piece of paper. It could be anywhere in like this ball, which is which like shows how it's three-dimensional. And how like are like he's most likely gonna be like the rows. So like this is kind of like the different like stages, like the F and the P, about how like it could be somewhere else, and like it's not all just like circles in the orbitals. It's not just like a sphere, like that's like almost like a what's that called? Like a dumbbell, like how it could be being like the walkways, and how it's like not just a circle, it could be like anywhere else. But like there's most likely being the walkways looking for people to sell stuff in. And that was our
Quantum mechanical model versus the Bohr's model.
and this was done by Austin Poker and Thomas Sergo.